Okay, so number 24 says cosecant squared over tangent squared. Cosecant squared over tangent squared equals cotangent squared over sine squared. Okay, so I think I'm going to work the left-hand side and just rewrite in terms of sines and cosines and see what I have. Well, actually, let's just look for a second. I need a cotangent squared in the numerator if I go left to right, yeah? Well, I have a tangent squared in the denominator. So, I guess in order to show my work, I'm going to actually do a step. I'm going to remove some things, although just drawing arrows would be fine. Cosecant squared is the same thing as sine squared in the denominator, so I'm just going to rewrite this as 1 over sine squared divided by 1 over cotangent squared to just show like the reciprocals, right? So then, if I multiply by the reciprocal, cotangent squared over 1, then I get cotangent squared over sine squared. And we're good. If you had done sines and cosines and said, so that would have been sine squared over cosine squared, flipped and multiplied cosine squared over sine squared, then you would have had to just see that that is now cotangent squared and there's your sine squared. But either way. Okay, 25. So 25 says negative cosecant squared times cosine squared equals negative cosecant squared plus 1. Okay. Sure. I'm just going to go ahead and rewrite this as negative 1 over sine squared times cosine squared. I'm going to work left to right. And then I'm going to say, well, that's negative cosine squared over sine squared. That's negative cotangent squared. And then I'm going to use my identity. Cotangent squared equals cosecant squared minus 1. So I'm going to say negative cosecant squared minus 1. Distribute my minus sign. I get negative cosecant squared plus 1. And we're good. Okay. If I had done it from this side, then I would have said negative cosecant squared plus 1. So if I had subtracted this over, and then I would have said that's negative cotangent squared. And negative cotangent squared I could split up as negative cosine squared over sine squared, and if you bring sine squared up to the top, you get cosecant squared. So that would have been the other way to work it. Alright, 26. 26 says secant squared plus cosine squared, cosecant, plus cosecant squared equals cosecant squared divided by cosine squared. So I am going to work the left-hand side, but I'm going to make sure that I'm aware of what my goal is. My goal is, oh, you can't even see it, cosecant squared over cosine squared, but here's the thing. Cosecant squared in the numerator is the same thing as sine squared in the denominator, so my goal is 1 over cosine squared times sine squared, in essence. So I'm going to rewrite this as 1 over cosine squared plus 1 over sine squared, and then do common denominator, multiply this top and bottom by sine squared. So this becomes sine squared over sine squared cosine squared, and this multiply top and bottom by cosine squared. So cosine squared over sine squared cosine squared, and I don't normally write this step, but I wanted to go ahead and show it on this one since I didn't show that I multiplied. So then I've got the numerator sine squared plus cosine squared over the common denominator sine squared cosine squared. Pythagorean identities tell me that sine squared plus cosine squared equals 1. So I've got 1 over sine squared times cosine squared. If I bring that up to the numerator, then I've got cosecant squared over cosine squared. And there we go. Okay. So let's look at number 27. So number 27 says cosine of x minus y over cosine x cosine y equals 1 plus tan x tan y. Okay, looks kind of weird, but cosine x minus y, the only thing I know to do with a problem like that is my sum and difference. So alpha is x, beta is y. Cosine of x minus y, oh sorry, is to do this. So it'd be cosine x cosine y. So we're going left to right. Cosine x cosine y, and then this is minus, so plus sine x sine y divided by cosine x cosine y, and hopefully it becomes pretty clear that at this point you want to split up the fraction. This divided by this plus this divided by that. So cosine x cosine y divided by cosine x cosine y. Thank you, Marbles. Okay. This is my dog getting right into my space. Hi, Marbles. Okay, okay, thank you for looking at the camera. And this is going to be plus sine x sine y divided by cosine x cosine y. Something divided by itself is 1. And then this can be split up because in the same way that I can say 2 times 3 divided by 4 times 6 is the same thing as 2 fourths times 3 sixths. I can split this up and say sine of x divided by cosine x and sine of y divided by cosine y is the same thing as tan x tan y. And there we go. That is that. Number 28 says 1 minus cosine 2x, okay, we're in double angles, divided by tan squared equals 1 plus cosine 2x. Interesting. Okay, so before I go anywhere with these, I'm going to remind myself of what I can do with 1 minus cosine 2x and 1 plus cosine 2x. If you look at the power reducing, I use those so often, although you don't have to, you can definitely use your double angle. It's just faster to go this route. Sine squared equals 1 minus cosine squared of 2x divided by 2. If I multiply by 2, then 1 minus cosine 2x is 2 sine squared. So I'm going to replace this with 2 sine squared over, and then I'm going to go ahead and replace tangent squared with sine squared over cosine squared. And then I'm going to remind myself that 1 plus cosine 2x is the same thing as 2 cosine squared. So just as a reminder, if I can get to 2 cosine squared, then I'm good. So I divided 2 sine squared by this fraction. I'm going to multiply by the reciprocal, cosine squared over sine squared. And then I can see that the sine squares will actually go away, and I'm left with 2 cosine squared. And I know that I'm good, but I'm going to go ahead and use this identity. Cosine squared is 1 plus cosine 2x divided by 2. So 1 plus cosine 2x all divided by 2. The 2's go away, and I'm left with 1 plus cosine of 2x. And there we go. My marbles. And then, well, that's the end of that page, so I'm going to end the video there, and then I'll keep on going.